Hello and welcome to the Peak Electronics booth. Peak Electronics is one of the leading manufacturers of DC-DC converters with a wide range of more than 20,000 standard types. This video is about selecting a DC-DC converter. In few steps we explain the most important criteria to select the converter optimized on the application needs. Ambient and environmental conditions influence the function of the DC-DC converter.
The proper functioning of a DC-DC converter is essentially influenced by the ambient conditions. In particular, the operating specifications defined in the datasheets must be adhered to. In many applications, negative ambient influences can, in most cases, at least be reduced or completely eliminated. First, the overvoltage. If a risk exists in an application that the DC-DC converter, even if only for a short time, is exposed to a high input voltage, for example due to voltage spikes, a transient voltage suppression TVS diode is fitted as effective protection. The response value, Zener voltage, of the diode should be at least 20% above the maximum expected operating voltage. Ideally, the input voltage range of the converter is chosen in such a manner that the voltage value of the Zener diode is within its permitted operating voltage range. TVS diodes, for example, the 1.5 KE series, can effectively limit greater than 1000 watts, 1 kilowatt, in the microsecond range. The use of a unipolar TVS diode is recommended with DC-DC converters. And the input protection. Building in input protection is always recommended. With the destruction of a converter through an external influence, a short circuit can be created in the input circuitry, which causes a correspondingly high flow of current. The result is that the converter literally burns out, or smouldering of the leads is caused. Instead of a melting fuse, a resettable fuse, such as a PTC fuse, can be installed. A fuse should always be built in when the applied voltage source to the converter has a very high power in order to supply many loads at the same time.
And how does the temperature influence the converter function?
No DC-DC converter operates in an ideal manner. In other words, with an efficiency of 100%. In order to be able to draw a certain amount of power at the output, a higher power must always be available at the input. The greater the difference between input power and output power, the greater the power loss, and thus heat dissipation that occurs in the converter. The converter can only transfer this heat to the surrounding environment through its outer surface. What is important is that the DC-DC converter does not become too hot inside. With regard to the specification in the datasheet for maximum ambient temperature, this value is purely a guideline value. Many different factors, such as mounting position, influences caused by neighboring components that generate heat, or packaging density of the application, can sometimes lead to substantial deviations from the specification. As a rule, the maximum ambient temperature must be revised downwards. In order to correctly dimension the application, also with regard to the thermal situation, some values are important, such as efficiency at a given output power and maximum allowable housing temperature. The power loss and heat dissipation can be calculated from the efficiency and the power. The maximum housing temperature can be simply measured with a temperature measuring instrument under real conditions. However, in the interest of a long operating life, the DC-DC converter should not be taken to the upper temperature limit. In particular, capacitors suffer due to high temperatures. In practice, it is advisable to remain below approximately 80 degrees centigrade as measured in contact to the surface of the housing. With converters having an output power greater than approximately 20 watts, the efficiency should be as high as possible. Peak Electronics P30WG series or P40WG series with 40 watts output power offers, for example, an efficiency of greater than 90%. If the output power of the P40WG module is used to the full, there is a power loss of about 4.5 watts. This heat must be dissipated by the relatively small module housing with a footprint of 25.4 millimeters by 50.8 millimeters. Therefore, the powerful converter, like many others, has a temperature derating. This means that the full output power can only be drawn up to a certain ambient temperature. If the ambient temperature is higher, only a lower power may be drawn, and hence the power loss declines, and the converter is no longer so warm. Roughly speaking, the following are given as safe guidelines. DIL 4, 6, 7, 8 packages should have a power loss of 0.5 watt maximum. DIL 24 packages, approximately 1.5 watt, 1 inch by 2 inch packages up to 2.5 watt, 1.6 inch by 2 inch packages up to 3 watt, and 2 inch by 2 inch packages up to 4 watt. These values are based on a maximum ambient temperature up to 50 degrees centigrade. When making the first calculation, if higher power loss values or higher ambient temperatures are expected, some leeway should be left for improved cooling solutions. Cooling of the module can be achieved through a fan or also by extending the surface of the converter available for cooling with a heat sink. However, what really counts is the measured temperature in contact to the surface of the housing of the converter.
Which further environmental conditions influence the functionality?
Humidity. Since most DC-DC converters are potted, the circuitry inside is well protected against high humidity. It is only the solder pins that can be damaged by condensation. A protective coating, varnish or similar, can provide a solution here. Nonetheless, the manufacturer's specifications relating to humidity should be complied with. In most cases, 5 to 95% non-condensing is commonly specified here. The specifications for non-potted converters must also be strictly observed. Air pressure only plays an important role with applications at high altitudes. Air pressure decreases with increased altitude. In other words, the air is less dense and can absorb less thermal energy. This must be taken into consideration in the power loss calculation. Vibration and shock. Potted converters have a high level of resistance to mechanical stresses. In most industrial applications, at the most, care must be taken to make good solder points when assembling the converter in the application. Where high demands are made, a system test is unavoidable. The solder joint strength can be increased by an additional screw-mounted plate, clamp or spring clip.
Which form factors are available?
Nearly all DC-DC converters are designed for printed circuit board mounting. Furthermore, Peak Electronics also offers a large range of DIN rail modules. Special solutions for chassis mounting, as well as potted modules with connecting pins or connecting terminals, are also available.